So to begin talking about graphing lines, we're going to talk about what's called the Cartesian coordinate plane. It is called the Cartesian coordinate plane after a famous mathematician, René Descartes. And basically what we have are two axes. We have the x-axis, which is the horizontal one, and we have the y-axis, which is the vertical one. They intersect at a point called the origin, which is right here in the middle. And we form four quadrants. 1, 2, 3, 4. They are numbered counterclockwise against the clock. And we start with Roman numeral 1, 2, 3, and 4. When we go to graph a point, remember that every single ordered pair is of the form x comma y. So if we were to do something like 4 comma negative 8, then we're going to go first to the 4 on the x-axis, and then we're going to go down to negative 8 on the y-axis. I'm trying to do this on the computer and it's a little difficult. So I go 4 and then down to negative 8. So there's the point 4 comma negative 8. Okay. So we're going to talk also about what's called slope. For IB purposes, we call this the gradient, which is rise over run. The symbol for gradient is m, lowercase m. And basically it's delta y over delta x. Delta, I don't know if you've seen it in physics or in any other science class. It's the change, basically the change of the y's over the change of the x. So y2 minus y1 over x2 minus x1. And let's say that I were to take another point, like the point negative 6 comma 0. And I'm supposed to figure out the slope between these 2 points. Okay, so here is negative 6 comma 0. It's negative 6 on the x-axis and 0 on the y-axis. You would want to label this x1, y1, and again, forgive me because I don't have a touch screen computer, so I have to do this on my keypad. So x2, y2, because remember this is my first point, so my first x, my first y, my second point, second x, second y. And that's how I would be able to figure out the slope in this case. And then of course we're going to talk about the equation of a line because that's how we're going to graph a line, and it's y equals mx plus c. For those of you who maybe didn't take an IB year 1 course last year, you're like, why isn't it y equals mx plus b? Well, IB makes it y equals mx plus c, c for constant, a number that doesn't change. So it's the same thing, it's still the y-intercept, but just so you realize they do call slope gradient, and instead of y equals mx plus b, we have y equals mx plus c. Graphing lines, a few things to remember. We read left to right. So in this particular case, left to right, this line is rising. Because the line is rising, that indicates that my answer for slope should be positive. My answer should be a positive number because the slope here is positive, the line is rising. When the line is falling, then that means that we should have a negative slope because from left to right, the line is falling. When you have a horizontal line, the slope is 0. Why? Because it's not rising ever, it's only running. So you're going to end up with an answer of 0 over some number. Sorry. So here, any horizontal line, and notice the zeros in the word horizontal, has a slope of 0. A vertical line, on the other hand, is always rising, never running. So what happens here is that we end up having some number like 5 over 0. And division by 0 is mathematically impossible. Therefore, we say that a vertical line has no slope, or we say the slope is undefined. So here are our first examples. There's 4 examples on graphing lines. Remember, y equals mx plus c. The slope or the gradient is m, and c is the y-intercept. So the first thing that we are going to do when we have to graph, like in this case, 2x plus y equals 4, is that we have to set the equation into slope-intercept form, gradient-intercept form. So the first thing we want to do is rewrite the problem. Let's go ahead and solve for y. Let's get the y by itself. So I'm going to get y equals negative 2x plus 4. Once you have it y equals, okay, once you've isolated the y, then here I can tell the gradient is negative 2, the slope is negative 2, and the y-intercept is 4. So what I'm going to do is go to 4 on the y-axis and put a point there. From that point, I'm going to follow what the slope tells me to do. The slope here is -2 or -2 over 1, right? Because slope is rise over run, so I want to see it as a fraction. So -2 over 1, which means I'm going to go down 2 and over 1. So here is my second point. I went down 2 over 1, and finally I get to connect these with a line. And yes, my slope is negative, so my line should be falling, and that kind of all makes sense. Let's take a look at example number 2. In example number 2, we have to graph -1/3 x minus y equals -5. In this case, we also want to start by getting the y by itself. So how am I going to get the y by itself here? You're going to have to take the -1/3 x and take it over to the other side. And then you're still going to be left with a -y, so you're going to have to divide everything by -1. So again, rewrite the problem. I moved the 1/3 x over to the other side. Then I divided everything by -1 because the y has to be left completely alone. Okay, y equals mx+c, the y has to be positive. So I divided everything by -1. Now I know my y-intercept is 5 and my gradient is -1/3. So I'm going to go to the y-axis and I'm going to put a point at 5. From 5, I'm going to follow what the slope says. Because here the slope is -1/3, that means I'm going to go down 1 and over 3. So then here is my next point. Go down 1 over 3, and last but not least, connected with a line. Again, my gradient is negative, so the line is falling from left to right. In question number 3, graph y minus 7 equals -8. In this case, I want to go ahead and add 7 to both sides to get the y by itself. So then I'm going to end up with y equals -8 plus 7, which means y equals -1. Y equals -1. If I go to -1, I don't have a slope, right? Because I don't see any x there. So that means my slope is 0. This is just a horizontal line. When you have y equals some number, it is just a horizontal line. So this is a horizontal line at y equals -1. And again, the slope of a horizontal line is 0. In example number 4, it's a little bit different because we have x plus 1 equals -3. I don't see a y at all. So I've been telling you all along, you got to get it into the form y equals mx+c, but here there's no y at all. So instead, I'm going to go ahead and get the x by itself. How? Subtract 1 from both sides, x equals -4. Because x equals -4, that tells me that this is a vertical line. So you go to the x-axis, okay? You come to -4 and you draw a vertical line going down 4. So that's basically how you have to graph lines. Again, you want to isolate the y equals mx+c, and then you want to identify your y-intercept and your slope, connect the points. If, remember I told you, the line is falling from left to right, then that means that we should have a negative slope. This means that if it's rising, we should have a positive slope. A horizontal line has a slope of 0. A vertical line has no slope or is undefined.